All right, I want to talk about the log conversion formula, okay? And then using that with our calculator here, okay? And of course, on your calculator, the keys you got to be familiar with are, okay, the natural log key and the its inverse, e to the x. I say there's no log key. The common log, the common log is buried in the catalog, okay? So once you go to the catalog, strike L, and there you go. You're going to look for the common log, okay? It's down there. There it is, log, okay? And there goes my, there. Okay, so there's log, and of course, say if I want a log of 1,000, then of course that should be 3, and there it is, right? Okay, so now let's look at the log conversion formula. We addressed a couple issues like this in class, but let's see. Okay, so you know that the log base 2 of 32 is equal to 5 because you know that 2 to the 5th is 32. But your calculator doesn't know that because, as you saw on your calculator, okay, you do not have log base 2. Okay, you have the common log and you have the natural log. So that's why we're going to use the log conversion formula. So here we are. So we're going to say here that the log 32, log base 2 of 32, log base 2 of 32 could be viewed as the natural log of 32. That's the natural log of the argument over the natural log of the base. Or you could look at it as the common log, okay, of 32 over the common log of 2. So, and of course we need to pull off the calculator in order to do this. So here we go. Let's execute this in common log first. Okay, so clear. Again, we're going to go common log, pick up the log. We're going to go log of 32 divided by the log of 2, right? So there we are, log of 8, and there it is, 5. So, and then if you wanted to go to the natural log, that's right on the keypad here, so we can get, that's a secondary key, ln of 32, and divided by the natural log of 2. And again, that reveals for us 5. So in the event that you needed to evaluate something like, well, what is the, I don't know, what is the log base pi of 57? Okay, well, certainly I have no idea. What I know is that that is some value, okay, x, whereas, you know, that's, well, let's call it x, okay, that's some value x, which is such that pi to the x is equal to 57. So the only way I can resolve this is to go to log conversion. So I'm just going to say it's the natural log of 57 over the natural log of pi, since natural log is right on the keypad there. So there we go. We go to the natural log of 57 divided by the natural log of pi, and there's pi, okay? And so that gives us the 3.53, right? Of course, it's, yeah, I keep losing it, 3.5318. 3.5318. So, in other words, that would imply that pi to that power, so I could actually do that. Let's see. Pi, let's see, so we can convince our calculator of this. Pi to this power should be 57. There it is, okay? So that's how we can use that log conversion. Now the other thing was that I said we could put it on any base we wanted. So we all know that the log base 8 of 64 is 2. But if we wanted to, we could interpret this log base 8 and log base 64 on another base entirely different. Well, for convenience, I'm going to say I'm going to put it on base 8, so base 2 rather. Log base 8 is 64 by log conversion is the log of the argument, but I'm going to say log base 2 is 64 over the log base 2 of 8, the log of the base. And of course we identify that as 6. For 8, their quotient is 2. So it's a very convenient rule to have, and we will make use of it, you know, from time to time. And again, for solving things like, okay, well, what is the log base 7 of 85? Again, I have no idea. I know 7 squared is 49, but again, your calculator could tell you that. Okay, so again, I'll default to the natural log again because that's right on the keypad. So natural log of 85 divided by the natural log of 7. Okay, natural log of 7, and that is it's at 283. Okay, 2.8307. All right, so that's 2.8307, which is to imply that 7 to the power 2.8307 should equal 85. And let's see. So we're going 7 raised to the power 2.8307 to 2.8307 is what did I do here? I'm sorry. The log base 7 of 85 is 2.28. I miscopied that. Let's go back and change that because I seemingly read that number off wrong. 2.28. 2.28. Okay, so now we can come in and resolve that. 2.283. So clear. 7 to the power 2.28. That's 2.283 is close enough to 85, but there again I didn't take all the decimal places, so you get the idea. All right, so you ought to try a couple of those just so you become familiar with the log conversion formula. Okay, all right, that'll do it for now. We'll do another video in a moment.